Hello everyone. In this session, I will share with you a second-order non-homogeneous linear differential equation in which the fs is the combination of the exponent, polynomial, or trigonometry. Now, let's look at the example. Obtain the particular solution for y double prime plus y equal to 2 sine square x, in which the initial condition is when x equal to 0, y equal to 2, and x equal to 0, y prime equal to 1. So in order to solve this question, first of all, you need to find the YC. Okay, you need to find the YC, which is the complementary function of the homogeneous equation. So you have y double prime plus y equal to 0. So you assume it is a homogeneous equation first. This one you change to the m squared plus 1 equal to 0. So m squared equal to minus 1. So equal to plus minus I. That is the imaginary equation. Imaginary root. So you can find the case based on the root. Since just now the root is a complex, therefore the case is case number 3, 2 complex conjugate alpha plus beta I. The alpha should be 0, the beta is 1. So the general solution is alpha, okay, exponent alpha x, a cos beta x plus b sin beta x. Okay, so the alpha based on alpha plus beta I, alpha is 0 and beta is 1. So exponent alpha 0, so you get 1. So you strip away this one, you substitute with 0, so you get exponent 0. Okay, so exponent 0, you will get 1. So here you will get a cos x, because beta is 1, plus b sin x. Okay, so this is the ycx. So second step, you need to find the yp, okay, because of the non-homogeneous. So your fx from the question is 2 sine square x. Okay, from the identity, okay, sine square x is equal to 1 minus cos 2x divided by 2. Okay, so this is the identity. So you can actually substitute the identity. Okay, you need the 2 square x, so this one should be equal to 1 minus cos 2x. So you substitute 1 minus cos 2x. Okay. So if you base on this answer, can you tell me what is the combination of? Is a combination of, one is a polynomial, and then cos x is a trigonometry. So I would say that this is the combination of polynomial and trigonometry. Therefore, your yp equal to, okay, this one is based on the table. Let's go to look at the table. So this is the table to assume the yp. So just now 1 is actually a polynomial, so yp is c. Okay, so case number 2. And then another one is a cos 2x. So cos 2x is a trigonometry, case 3. So your assumed yp is a c cos nx plus d sin nx. Therefore, your yp is equal to c plus d cos 2x. The nx, you still remember the nx. Okay, just now I show you is the nx, right? The n there, you refer, the n is, you copy back the value from the fx. So if it's a cos 3x, sure here it's cos 3x. But now the value here is cos 2x. So the n also 2. Okay. And then plus with sine 2x. So this is the case 2. And this one is the case 3. So it's a combination of polynomial and trigonometry. Then you check. So don't forget to check whether this yp is same as yc or not. Okay, if you check here, this is the yc, a cos x plus b sin x. And then your yp is c plus d cos 2x. This is cos x, this is cos 2x, this is not the same. Okay, this is e sin 2x, this is b sin x, so it is not the same. Therefore, I would say that yp is not the same with yc. Okay, then we can proceed to the next step, that is to find the yp prime and yp double prime. Okay, so based on the yp here, you can find the yp prime. Okay, yp prime, okay, based on this one, what we can get. Okay, so this one you have nothing. And then for this one, okay, differentiate the d cos 2x, you will get d and then negative 2 sin 2x. So you get d negative 2 sin 2x. Okay, you differentiate the cos, you get negative sign. And then plus e, okay, differentiate of sine, you get cos. So 2x, so you have a 2 cos 2x. This is the yp, and then you need to get the yp double prime. Okay, yp double prime, what do you get? So from here you get negative 4d cos 2x. And then differentiate cos, you get minus sine. So you got minus. So initial you have 2 here, so differentiate again, so you get negative 4e sine 2x. Okay, so after you get this yp prime and yp double prime, you substitute into the differential equation. So from your equation, that is y double prime plus yp equal to 2 sine, oops, not 2 sine, equal to 1 minus cos 2x. Okay, so you can substitute the value y double prime and y into the differential equation. So if you look at here, this is negative 4d cos 2x. Here also d cos 2x. So we can simplify negative 4 plus 1. So you get negative 3 d cos 2x. And also we can simplify this one, negative 4e sin 2x with the e sin 2x. So negative 3 plus 1 and negative 4 plus 1, you get negative 3. So negative 3e sin 2x. Then plus with c equal to 1 minus cos 2x. Then you compare the coefficient. Okay, if I want to compare the cos 2x, okay, I have this cos 2x, okay, here also cos 2x. So at the left hand side, I got negative 3d. At the right hand side, I have negative 1. So the d is 1 over 3. Okay. Then I compare with c. Okay. C at the left hand side, I have 1. C equal to 1. Yes. Then I haven't compared for the sign. So I compare for the sine 2x. Okay, at the left hand side, I get negative 3e. At the right hand side, I get 0. So e is equal to 0. Therefore, the particular integral, we call it particular integral, yp equal to c plus d cos 2x plus e sine 2x. So c, the value is 1, d, the value is 1 over 3. E is 0. So this is the answer. Do you get it now? Okay, after you find for the YC and you find the YP, now you come to the general solution. Okay, step number 5 is the general solution. Y equal to YC plus YP, where the YC is A cos X plus B sin X. And then yp is plus 1 over 3 cos 2x. Now the question requests you to find the value of a and b by giving you a initial condition. So the initial condition is when x equal to 0, y equal to 2, and when x equal to 0, y prime equal to 1. Alright, so y prime, so I straight away substitute the value. So this is the equation of the y. Now I substitute using this value, initial value. So y equal to 2 when x equal to 0. Okay. You know that cos 0 equal to 1, sin 0 equal to 0, here equal to 1. So you have 2 equal to a plus 1 over 3. Now your a is equal to 2 over 3. Okay. Next, we go to the y prime equal to 1 when x equal to 0. So this means that when you say that y prime 0, this means that what? You need to differentiate the equation y, then only you can get the y prime. After that, you can just substitute the value or substitute the initial value. Okay. So what is the y prime? Okay, based on this equation, y prime is, you differentiate the a cos x, you get negative a sin x. Okay, and then differentiate the b sin x, you get b cos x. And then differentiate this one, you get nothing. And then you differentiate this one, you get, differentiate the cos, you get negative sign. So negative 2 over 3 sin 2x. Okay, now you can substitute the initial value. Okay, y prime equal to 0 when x equal to 0. So now this is 0, this is 1, this is 0. 1 equal to b. Therefore, your particular Solution y equal to 2 over 3. This is the value of a plus b. B is 1. So remember the sign x plus 1 over 3 cos 2x. Okay, so this is how you answer for the question 2, example 2.9, 2.8. Next, we will look at another example, also a combination of the trigonometry. So solve the second order differential equation y double prime plus 16y equal to 2 cos x cos 3x. In order to solve this question, first of all, again, you need to treat it as a homogeneous equation. Then you find the complementary function. That is, we call it as the YC. So step 1 is find the YC. So from this equation, we know that that is the m squared plus 16 equal to 0. So m equal to negative 16. So that is plus minus 4i. Okay, again, this is same as the previous case. That is a complex. Therefore, our YC is a cos 4x. Okay, the n refer to the 4 plus b sine 4x. Okay, this is quite simple because we treat it as a homogeneous differential equation. Now, the question given you the fx. So now we need to find the yp. And the fx given in the equation is 2 cos x cos 3x. Okay, 2 cos x cos 3x. And then we need to use the identity, in which the identity refer to this equation is 2 cos x cos y. We can simplify as cos x plus y plus cos x minus y. So this is the identity for the cos x. Sorry, I have a cos. For the identity of the cos x cos y. So this 2 cos x cos 3x, I can just separate it or split it. So based on this identity, cos x cos y, here you have cos x cos 3x. Okay, this one I assume is a x, this one I assume as a y. So I will get cos x plus y. Alright, so cos x plus y, so your y is 3x plus with cos x minus y, so x minus 3x. Therefore, there is a cos 4x plus cos negative 2x. So this one will equivalent to cos 4x plus cos 2x. Why I said that this one is plus? Where is the negative here? Actually, cos negative 2x is equivalent to cos 2x. Okay, that's why I simplified become cos 2x. So this answer, cos 4x plus cos 2x, is a combination of trigonometry. Therefore, your YP equal to, okay, YP you can refer to the table. By referring to this table, YP table, trigonometry is C cos nx plus D sin nx. C cos and x. N is referred to the value of 4 here. So C cos 4x plus D sin 4x, and then plus with E cos 2x plus F sin 2x. Okay, this one is referred to the YP1, and this one we refer to the YP2. And then we check this YP, is it same as the YC or not? Same or not same? A cos 4x, C cos 4x is same. So if it is same, we got to multiply the x with the YP. Therefore, we have the CX cos 4x plus DX sin 4x so this part we will assume it as a YP1 because it's a same. Okay, YP same as YC, so we separate it into two parts. There is YP1 and YP2. So this YP1 is CX cos 4x plus DS sin 4x. And then we check again whether this YP is it the same with the YC. Okay, YP CX cos 4x. Now this A cos 4x, B sin 4x, so it's not the same. Okay, so we said that it is not the same. So the third step is to find the YP1 prime and YP1 double prime. Okay, just now we have this one, fx. Where's the fx? Fx. Okay, fx you have the cos 4x and cos 2x. So we solve for the cos 4x. Okay, so for this one is for the fx of equal to cos 4x. YP1 prime equal to CX. So YP prime, you get it from the YP1. So this is assumed as U, this is assumed as V. So U, V prime, you get negative 4 sin 4x plus V is cos 4x. U prime, you get C. Okay. And then for the second part, okay, this one also U and V. Okay, U dx, V prime, you get 4 cos 4x plus V is D. Okay, it's a sin 4x. U prime, you get D. So when I simplify, I collect the sin 4x and cos 4x. For the sin 4x, I have a negative 4cx. Negative 4cx plus, again with the D, okay, plus D. So this is the sin 4x plus with 4dx and 4c. cos 4x. Okay, cos 4x, so you have the 4dx plus c only, not cx, plus c only. Okay, from the yp1 prime, you get the yp1 double prime. Okay, so from here you get negative 4 cx, again is a uv prime plus vu prime. And then second one also the same. Okay, then we can simplify. We collect all the cos x. Okay, we collect all the cos x, cos 4x. So this one you get negative 16 cx. And then another cos 4x, you have a 4d. This is 4d. Okay, this is also 4x. So you get 4d and 4d, you get 8d. So plus 8d. So this one is a cos 4x. And then plus with sine 4x. So you collect all the sine 4x, you get negative 4c, so negative 8c. And then negative, so this one is negative 16dx. So negative 16 dx, we multiply with sine 4x. Okay, so after you get yp1 prime, yp1 double prime, you can substitute into the value. So y double prime plus 16y equal to cos 4x. Okay, you substitute all the y prime and y. Equal to cos 4x. Okay, now we can compare the coefficient. Okay, let's simplify it first before we can compare it. Okay, negative 16cx for the cos 4x. Here also got cos 4x. So negative 16cx plus with 16cx, so we can cancel out. And then we left at d. So at d cos 4x. And then negative at c, 16, negative at c sine 4x. And then plus, okay, this one nothing to cancel, so you get negative at c sine 4x. And then this one, negative 16 dx plus with 16 dx, so cancel out. Okay, then equivalent to cos 4x. So you compare the coefficient of 4x. Cos 4x, you get 8d at the left hand side, right hand side you get 1. So d equal to 1 over 8. And then if you compare again for the c, so you get left hand side is negative 8c, and right hand side is 0, so C equal to 0. Therefore, your YP1 equal to 1 over 8 x sine 4x. Okay, your YP1, okay, negative 1 over x sine 4x. Okay, that is the YP1. Okay, YP1, you substitute the value of C and D. Okay, C you get all 0 and D you get the value of 1 over x. So 1 over x sine 4x. So next we go to the second one, that is the YP2 for the fx of cos 2x. Okay, we solve for the fx equal to cos 2x. So your YP2 equal to e cos 2x plus f sine 2x. So check again this YP same as YC or not. So this is your YP2. Okay, P2 e cos 2x and 4 sine 2x. Now check back the YC. Your YC is a cos 4x. This is 4, just now it's 2x. So it's not the same. So YP not the same with YC. Therefore, that is the latest YP2. So YP2 prime is equal to, you differentiate the e cos 2x, you get negative 2e sine 2x. And then you differentiate sine 2x, you get 2f cos 2x. Okay, next you differentiate again the YP2 prime. So you get negative 4. So because you have the sine 2x, so you have negative 4 e cos 2x. And then differentiate cos, you get minus sine, so minus 4f sine 2x. Okay, so after you get all this value, you substitute it into the equation again, same as the previous procedure. Now you want to compare for the coefficient of cos 2x. So first of all, you substitute in the y double prime from here, okay, into the differential equation. And then plus the 16y. Which is equivalent to cos 2x. Okay, you can simplify. Cos 2x, this is cos 2x also. So negative 4 plus 16, we get positive 12e cos 2x. Okay, and then you can simplify this one, negative 4f plus 16f. So that one is plus 12f sine 2x equal to cos 2x. So you compare the coefficient of the cos 2x, you get 12e equal to 1. Okay, 12e for the compared to x, you have 12e, and then for the right hand side, you have only 1. So e equal to 1 over 12. And then you compare for the sine 2x. At the left hand side, you have 12f. At the right hand side is 0. So f equal to 0. YP2 equal to 1 over 12. Okay. We want to find the E and F, right? The E is like 1 over 12. F is 0. So you get negative, you get 1 over 12 cos 2x. So this is YP, this one. E cos 2x. So your E is 1 over 12. Next, you write down your general solution. That is y equal to yc plus yp1 plus yp2, which is equivalent to a cos 4x plus b sine 4x plus 1 over 8 x sine 4x plus 1 over 12 cos 2x. So that's all for another example on the combination of trigonometry. That's all for today, and thank you for watching. If you like my video, please like my YouTube video. Thank you.